Hello again and welcome back. My name is Michael Fudge and this is lesson 14 in our series on learning to program in Java. This lesson will focus on array lists and collections. On the agenda for today, first we'll look at what is a collection and what is an array list. Then we'll take a look at how collections compare to arrays, something that you already know and have learned. And then of course there'll be examples, and more examples. Let's start out by answering the question, what are collections? Collections are similar to arrays in that they're groups of objects with multiple elements accessed under the same variable name. The ArrayList class is an example of a specific implementation of a collection. There's other types of collections as well, but the most popular one and the one we'll be using today is called the ArrayList. Collections contain special methods for managing objects, that is, adding an object to the collection, finding an object in the collection, indexing a specific value in the collection, and removing objects from the collection. So here's some examples of collections in real life, like a poker hand or a card hand. In a card hand, you might have 3 or 4 cards in your hand or 7 cards in your hand. And so the difference between an array and a collection is that an array is always of a fixed size, where a collection can be of a variable size. So this line of code we see up here first creates an array list of type card. So see, every collection needs to have a data type of the objects that it's collecting. So this would say I'm collecting cards, and I'm going to call that variable hand, and it's going to be a new array list. And then I can leave this out. You could usually put in card here if you want, but you don't have to. Or another example of a collection that occurs often on computers is an email inbox, which is a collection of emails. So I have ArrayList email, a collection of emails, and I'm calling it inbox. And again, it's a new array list. When a new mail message arrives, I'm adding an email message to my inbox. When I delete a message from my inbox because I've read it, I'm removing that message from the inbox. So collections are dynamic in sizes. They go up and they go down as you call methods to add and remove objects from them. Let's take a moment and discuss how arrays and collections are different. So like an array, collections hold more than one object. So up here I have an array of cards called hand, and up here I have an array list of card called hand. But unlike an array, they are not of fixed size. So when I declare my array of cards, you notice I say new card 7. So what I'm saying is set aside 7 slots in the computer memory to store the cards. Whether I use all 7 or not, inconsequential. The array list is dynamic. When you define the array list, you do not have to initialize how many elements are going to be in the array. And you can dynamically add and remove elements and resize the array list accordingly. The disadvantage is that arrays can use primitive types like ints and doubles, whereas collections cannot. Every data type used in a collection must be of an object type. Ints and doubles are not. That's why there's the built-in objects integer and double with a capital D. These are the object representations of the primitive types int and double. For example, when we make an array of grades, we might just say int array grades equals new int of size 20, making 20 contiguous blocks of integers. The second example down here says array list integer. It doesn't say int, because again, when you declare a collection, which an array list is, you always must use an object. So integer is the object representation of int. And then again, the advantage of using a collection is right now I'm not allocating any memory to store integers, but as I start calling out grades.add, I will be adding integers into the collection and then consuming memory accordingly. Of course, I will demonstrate this through my examples, and through using the debugger you can see exactly what I'm talking about. Okay, it's time to get into it. Let's jump into the examples, and we'll start with just a simple array list of integers that we'll use to store student grades. And then from there, we'll progress into array lists of objects, repeating kind of the student example we did in the previous lesson. Okay, here I am in my NetBeans IDE, and I've already created a new project called ArrayList Basics, and I'm in the main method here, and I'm just going to start out by creating an array list of integers, and then adding some grades to my variable. So I want to say array list, that's my collection type, and it's going to hold integers. And I'm going to call this variable grades because it's going to be a collection of student grades. And now I need to initialize it, new array list. Now, normally you might think you would have to do this to specify, if the data type is array list integer, then I need to say new array list integer. But I don't need to say integer over here. It's implied from the fact that I said array list integer over here, so I don't need that. Every constructor needs parentheses even if it has no arguments. Now you can see I'm redlining here, and that's because I cannot find the symbol array list. Once again, I have to hit my Control-Shift-I to include via import the package that I need, Java Util ArrayList class from the Java Util package. And now what I get via magic is when I type in grades, because it's a collection, and when I hit grades dot, I see a bunch of members here, like add. This allows me to add an integer to my collection. I can also add at a specific index that element. I can also add all based on another collection. So I can make one collection and then add all the things in one collection into another collection. I can also check to see that the object is in the collection using contains. Or I can get one object out of the collection by its index. Or I can look for an object in the collection and return its index. I can also remove a specific object by its object or by its index. And lastly, I can get the size of the collection, that is how many items are in the collection, or I can convert the collection into an array if I want. These are all useful utility methods, and I didn't have to write a single one. I get them for free because I'm using this type. Awesome. So let's add some grades here. I'm adding a 90. Let's add an 85. Let's add a 70. And then let's enumerate our collection. How about we use a for loop? Just like arrays, they're zero-based collections. So I would say I is 0, I is less than grades size. How many are in the collection? I don't know. I'm just going to find out using grades size. Then for each item in the collection, what am I going to do? Well, I think I'll do this. Let's print the grade out. Grade number equals, so grade number I is grades dot get I. And let's do the home run hit and just run it, see what it looks like. Then of course we'll step through it so you can kind of get a deal what's going on. So I run my program and I get grade 0 is a 90, grade 1 is an 85, grade 2 is a 70. Nothing spectacular, but at least it gets the point across. You'll notice here that I don't index these like I do an array. I have to call a method of the collection, right? I say, instead of, if this were an array, I would say grades sub I. But since it's a collection, I need to say grades dot get the value at position I. So the left is used for an array, the right is used for a collection. What you can't do with an array is remove, the first element of the array. You can't do it, but I can do that easily in a collection by saying something like this. Grades dot remove, and then let's give it an index. Let's remove the grade at position 1, which so happens to be the 85. Okay. What I'd like to do now is put a breakpoint right here on line 10, and then I'm going to debug the program, and it's going to stop right at line 10, and then I'm going to step through it a line at a time using F8. because what I want to focus on here are the variables, right? If you look at this array list, it currently is of size 0. See that? And if I open up the array list, nothing exciting happens because there's nothing in it. If I press F8, it will execute this grades add 90, and now I have one item in my array list. And when I open it up, I have an index of 0, and that has the value 90. And again, when I do this 2 more times, it will now have 3 items in the array list, a 90, an 85, and of course a 70. So this for loop then will just kind of go through each item in the array, right, and print it out. But what I want you to do is focus on this line 19 here, because this is something you cannot do with an array. You can only do this with a collection type class like an array list. I'm going to take this array list and I'm going to remove this element that's right in the middle of the array. I'm going to remove element 1. Grades remove 1. I'm going to remove the integer at position 1. And if you look, it did it, and then it renumbered these so that they're once again continuous, and now I'm left with the grades 70 and 90, right? And those were inserted first and last. Pretty cool. Can't do that with an array. This next example will demonstrate 2 ways that you can enumerate a collection. So rather than watching me type, what we'll do in this particular case is just kind of read through the code I have. In line 12, I'm creating my array list of student, and I'm calling it Psych 101. That's going to be the name of my class. And I have a class that I made called Student Java, and it's your typical student class. It's got 2 private members, name and GPA. And when you create a student, you pass in the name and the GPA. And you can always use the getters or setters to get the name or the GPA. And then it has an overridden toString method so it can print out what a student looks like. So in lines 15, 16, 17, and 18, I'm adding to my Psych 101 collection of students. I'm adding a new student named Bob with a 2.9 GPA, a new student named Dave with a 3.2 GPA, etc., etc. So I'm adding 4 students. Then down here, I'm printing out student a tab GPA. This is just going to kind of print out the top of my table. And if you look, I have a for loop here. And then I have the same thing down here and a different for loop here. And this is the for loop that you just saw in the previous example, where I start with an index or a loop control variable. And I say, while that is less than the size of the collection, increment, and then get the student at position I. This top code, this is a different way to write a for loop when you have a collection. I think this is a neater and cleaner way to do it. This is the equivalent of saying like for each. So what I'm saying here is for each student, which I'm going to call S, in my collection of all students, which is Psych 101. What do I want to do? I just want to print out that student S. The point of this exercise is that both this for loop here and this for loop down here, they do exactly the same thing. The only difference is the way that I structured the for loop. And you can see that this one up here is a little shorter. There's a lot less typing. It's a little easier to read. Again, I want to kind of explain it because they both do the same thing. If I run this, you'll see that there's no difference in output between the top for loop and the bottom for loop. The only real difference is that one of them indexes the collection with a loop control variable, and the other one does not index the collection, it enumerates the collection. Let's put a breakpoint right here on line 21, just so you can see what happens when I debug this program and we fall into this for loop. So I'm going to start it with a debug, and then we hit this breakpoint. Now I'm going to hit F8. Now it says for student S in Psych 101. So Psych 101 has 4 elements in the collection. S just so happens at this point to be the exact same thing as the first element. I don't know if you can see that. But name and GPA of Psych 101 0, Bob 29, and then S is Bob 29. So this for loop will go through 0, 1, 2, and 3 each time, but I don't need a loop control variable I to do that. It just knows to start and run through the entire collection, each time pulling the indexed value out of the collection and saving it as S, so that S refers to that particular element in the collection. So first time through, it's Bob29. I'm going to hit F8 until I get it again. Second time through, it's Dave32. Third time through, of course, it's going to be Sally with a 4.0. And the last time through, it's going to be Alice with a 3.15. And then it knows when to stop because it runs out of items in the collection. So I hope you see what's going on here. This version of the for loop is much more simple to write and easier to understand. There's a little bit of magic by how it works, but if you understand how to read it, it makes perfect sense. It's like saying for each student S in my collection, Psych 101. If you think about it that way, think about, you have a bunch of students in your class and you just point a finger at each one until you're done. That's exactly what's happening. You'll see me when I enumerate collections, I'll use this syntax a lot because it's a lot more neat and clean. Okay, here we are in our last example for the day. Once again, we still have the same old student Java, so I'm not going to run through that again. And this time what I'm going to show you is how you can easily manipulate the values in a collection, much better than you could ever do with an array. I'll start by demonstrating that you can resize a collection however you want, and then I'll finish by showing you how you can do what's called a swap, which is change positions of items in the collection. And that'll introduce to you the common pattern we use for swapping values in a collection. So this first line here creates my Psych 101 class, which is an array list of students. And then I'm adding one student Bob, another student Dave, another student Sally, nothing crazy. Rather than me throwing a bunch of for loops all over the place, what I did was I wrote a method called print students here. And print students is defined as follows. It prints out a student, then a GPA, like you see down here in my output, student and GPA, and then a couple of dashes. Then it prints all the students and their GPAs. I used the old for syntax only because I want to show you how quickly I can change that for old for syntax into the new for syntax. Rather than say all this, which can be a pain to read, I'm going to say for student S colon AL, because AL is my array list of students. Then rather than saying this, I'm just going to say s.println. Let's run it and make sure I didn't break anything. Perfect. Still does it. So you can see this code is much cleaner than what I had. A lot less cruft in the code, if you will. So let's go back up to my main method and kind of dissect this a little more. So I'm printing out my students. Then I'm removing a student from the collection and putting that student in another variable called temp. Then I'm printing the students out again, and then I'm adding that student back. But I'm removing the first one, and then I'm adding this student to the end, so it should change the order of the students. Let's take a look. I'm going to put a breakpoint on line 19. Let me debug it. Let's go ahead and step over it. There's my 3 students it printed. Then it's going to remove Bob, because Bob is the first item. See that? It removed Bob. Bob 29 GPA, that's what it removed. Then it's going to print that out, and now you're going to see that Bob is missing. Then it's going to add Bob back in, but now Bob gets added at the end of the array list. See that? Dave, Sally, Bob, whereas when we started it was Bob, Dave, Sally. And then just to top it off, I'm going to add another student, Bill. And now I get Dave, Sally, Bob, Bill. Lines 27 through 31, these lines of code here implement what are called the swap pattern. And the swap pattern is what we use to switch elements in an array or a collection. It's a common thing that we need when we're doing a sort, when we want to sort items in the collection. When we want to do our own type of sort, we need to be able to move elements around, rearrange them. So when we swap things in real life, you have two hands, right? So you put your one hand on one thing, one hand on the other thing, and you switch them, right? But as we've seen with things like dice rollers and stuff like that, when it comes to computers, computers can't do two things at once. They have to do everything serially. So the only way that we can swap, imagine trying to swap a set of cards and you only have one hand to use. You have to take one card and move it out of the list and put it somewhere else. Then take the other card, move it into the other position, and then take the card that you put somewhere else and put it back in the position that you just fixed. So if you don't believe me, lay out 10 cards in front of you and try to swap them with two hands. Take two arbitrary cards and swap them. Then try to swap them with one hand, and you'll see exactly what I'm talking about. How we implement the swap pattern is as follows. You get the element first and put it in a temporary variable. Then you replace the element in the position that you just got. Then you replace the second element with the temporary variable. Let me run through it and show you what happens here. So in the first step, I'm going to get person 1, which is Sally. And because I didn't remove Sally, I just got Sally. So I have a copy. If I go back and look at the array list, it's still 4 elements in the array. And this one is still Sally. See that? So I didn't take Sally out. Then the next thing I'm going to do is I'm going to take whoever's at the other position I want to swap, which is Bob, and I'm going to copy Bob into Sally's slot. So watch what happens here. This line here says, set who you got at position 2 into position 1. So now what I have is something a little messy. I have Bob in position 2 and Bob in position 1. So Bob has been copied. Now my last step to clean this up is I need to take temp, which has Sally in it, and I need to copy Sally over the second Bob. So I'm taking Sally here and I'm copying over the second Bob. And now in effect I have swapped Sally and Bob. Let me print that out and show you. So before we had Dave, Sally, Bob, Bill, and now we have Dave, Bob, Sally, Bill. The swap. And that concludes our introduction to array lists. Join me for lesson 15 when we look at sorting and searching algorithms. Should be a great time. Once again, I appreciate you watching these videos and welcome your questions, comments, and feedback on YouTube. Have a great day. Bye now.